Welcome to the video for algebra review about ratios and proportions. This is the third lesson in chapter 1. Going ahead and taking a look at some vocabulary. Ratios are a comparison of two numbers using division. There are several ways to write ratios. You can use the word 2, 3 to 4. You can use a colon, still pronounced and read as 3 to 4, or as a fraction, 3/4, 3/4, but when we're using it as a comparison, we would say 3 to 4. This is starred because this is the way that we can use the numbers mathematically. So though we can reference and compare things using the word 2 and the colon, this is the form it needs to be in to actually use it mathematically. Proportions is when two ratios are equal. It can be used to extend and find unknown information. A scale factor is the ratio that represents a conversion used to change the size of a figure. I'm going to stop here and say really quickly that the word ratio is used in both of these definitions. So understanding that a ratio is a comparison, we are going to be using proportions to proportionally figure out unknown information comparing different factors. And so a scale factor is a specific, think about a map legend where there's a specific relationship that is used over and over again. Lastly, to be similar, figures that are the same shape but not the same size. With similar figures, I always think about clothing, about t-shirts, for example, something that comes in an extra small in that same style, but then a XXX large, so a XXXL, in order for it to be the same shirt, the same shape of the shirt, it's just not going to be the same size. So those would be considered similar figures. This is really where the algebra review comes in now, how to solve basic proportions. The steps are right there. We will cross multiply, simplify, and then we will divide. So taking a look at one problem at a time, 9/6 equals x/10. These are proportions because there are two ratios or two fractions set equal to each other. You cross multiply, which means doing this like X mark or shoelace kind of math work, 9 times 10 and x times 6. When you do that, so 9 times 10 is the 90, x times 6 is 6x, and then you solve that by dividing by 6 on both sides, so x equals 15. In the next problem, this problem has an expression, x plus 5. So when you do the multiplication, 7 times 5 is still just 7 times 5. But when you do this multiplication of 10 times the x plus 5, we need to recognize that that needs to be distributed. So it's not just 10 times x, it's 10 times the x plus 5. So that needs to be distributed out to be 10x plus 50. That's the simplifying step here. And then really also the next step is also, it's really solving, but it's simplifying down to that division and just using the algebra skills there. So distributing to get the 10x plus 50, subtracting 50 from both sides. And notice in this answer we do have a negative number. Negative numbers are fine. You just have to realize, think about whether or not it makes sense if it's a word problem. Last one, this one has two expressions in the numerator, x plus 4 and x minus 2. So there's just going to be some double distribution. There's going to be distribution on the left and on the right. And so you just take care of that and solve it algebraically. 5x minus 10, 7x plus 28. I prefer to keep my variable positive, so I subtracted 5x from both sides instead of subtracting 7x. It doesn't really matter as long as you do it correctly. And since I chose to move the 5x to the right, I had to subtract the 28 and move it to the left. So I end up with negative 38 equals a positive 2x. Either way, we end up with a negative x value. Again, that's fine. So really when we start to get into this green work, things can start to look a little bit different on your paper or mine, personal preference in the order of solving these steps. As we start to look at word problems here, this is where the scale factor will come in, but it's not necessarily going to, every problem won't have the term scale factor in it. The deal is that we just want to make sure we're using a pattern because we are setting fractions equal to each other, so we want to make sure we're using a pattern that makes sense. So let's go ahead and take a look at these word problems. So the first one says, in a certain classroom, the ratio of boys to girls is 3 to 2. If there are 12 boys, how many girls are there? So it says the ratio of boys to girls is 3 to 2. Technically, it could say the scale factor is 3 to 2. Ratio and that continual scale factor really are the same thing. We just generally don't use it when we're comparing. Scale factor kind of is like growing and shrinking figures and not necessarily boys to girls sort of ratios. So if there are 12 boys, how many girls are there? So the ratio that we're going to set up is boys to girls is 3 to 2. And I'm just kind of like moving along here. Boys to girls is 3 over 2. So if we have 12 boys, and this is where the pattern comes in, it's 3 boys to 2 girls. If it's 12 boys, the 12 has to go on top. Then we cross multiply to get 3g equals 24 and solve. So we need a pattern in a proportion equation and cross multiply and solve. So in B, at a recent party, it cost $9.50 for refreshments for 10 guests. At this rate, how much would it cost for refreshments for 80 guests? So there are lots of different ways to answer this question. A lot of times with proportions, especially even some of you may have figured out that there were 8 girls without having to cross multiply. So I will tell you that there will be some flexibility in your work here with these. I'm just going to use proportions to show you that proportions are helpful. So the proportion that I decided to set up is that if it's $9.50 for 10 guests, how much will it be for 80 guests? So money, the cost over the number of people it's feeding. So how much will it cost if I need to feed that many people? Cross multiply and divide, I get $76. Last problem, a certain shade of green paint is made from 5 parts yellow mixed with 3 parts blue. If 2 cans of yellow are used, how many cans of blue should be used? So this is a good problem because we're trying to get a specific shade of green. So in order to be consistent, we have to mix at a certain ratio of blue and yellow. And so 5 parts yellow, 3 parts blue. If we have 2 cans of yellow, how many cans of blue should we use? So the parts just means that it could be any measurement. It could be ounces, it could be cups, it could be gallons, it could be cans. So if I have 2 cans of yellow, how much blue do I need if I need a 5 to 3 relationship? So the proportion I'm going to use is if yellow to blue is 5 to 3, then this is what I'm actually solving here. 5 yellow to 3 blue. Well, if I have 2 yellow, how many blue do I need? And it's going to be 1.2 cans. So I'm not going to need an entire second can for the blue, just 1 2/10 of it, which I know can be tricky to actually measure out, but that's the way it works in order to get that perfect shade of green. These next set of problems have to do more with the scales and the models and blueprints and more building sort of language than just kind of everyday proportion problems. Okay, so taking a look at the first one, a scale model has a length of 40 centimeters. The original had a length of 25 centimeters. Determine the scale factor. So we have a relationship of 40 centimeters to 25 centimeters, and we're determining the scale factor. So this is not going to be a proportion problem necessarily. We're trying to figure out what is the relationship. When you're asked to find the scale factor, it's what is that relationship? Well, a 40 centimeter piece is representing something that's actually 25 centimeters. Then every 8 centimeters is representing 5 centimeters. So this is just simplifying. 40 to 25 simplifies as 8 over 5. And simplifying is something you guys can do in your calculator, but that's where the fraction form comes in, because this is how we would type it into our calculator, 40 over 25, to simplify it down. So the model is larger, so that's why it's a larger number on top. The model is something that's representing a smaller object, whatever that object might be. The next one is a map. Says a map shows an 8-kilometer distance as 40 centimeters. What is the scale? Then use the scale factor to determine how far apart it is. So let's take a look at this one. So we have 8 kilometers is 40 centimeters. And this one, it doesn't tell us specifically how to set it up, so you could have 8 kilometers first if you wanted. This is going from smaller to bigger. It's very important that you pay attention to your labels. 40 centimeters, those are the little tick marks. There's 30 of them on one ruler. Kilometers is the unit that's much closer to a mile measurement. So 40 centimeters on a map is representing 8 kilometers. Then for 1 kilometer, it would be 5 centimeters. And again, this is just simplifying it. So this in purple is that scale factor. It's that scale relationship there. And so we can use that to figure out, okay, well, if it's 70 centimeters apart on the map, how many kilometers is it actually going to be in real life? So you cross multiply and solve, you end up getting 14. I'm not focusing so much on the solving part here as I am the actual setup. So 40 compares and matches to 8. That simplifies to 5 and 1. You can use the 40 and 8 here, but you're getting much bigger numbers as opposed to just using 5 and 1 and doing a real quick multiplication and division to get 14. The last one in this section says the blueprint of a building shows a room to be 4 inches long, which is actually 10 feet in real life. If the blueprint shows a room to be 5 inches long, how long is that in real life? So 4 inches long means that it's 10 feet. Well, if it's 5 inches long, how long is that in real life? So the original given pattern, the given matching set is that 4 inches represents 10 feet. You can simplify this if you want to, but we don't have to. It's not specifically asking for a scale. It just says to find how long it is in real life. So if 4 inches represents 10 feet, then 5 inches would represent how many feet. There's the pattern, inches over feet, inches over feet. This is the given length. It looks like 4 inches long, it's 10 feet. So we're trying to figure out what 5 inches would be. Cross multiply and divide, it's 12.5 feet. Now taking a look at some geometrical shapes here, we have triangles and we're determining the scale factor between the two similar triangles. So we're told that they're similar. We're just trying to figure out the relationship essentially. How does this smaller one compare to this bigger one? Some of you may have seen right away that it's half the size, the smaller one is half the size, or maybe you saw it as the bigger one is twice as big. These things are saying the same relationship. The 3 matches with the 6, the 8 matches with the 16, 3 is half of 6, 8 is half of 16. This is a fraction, the 3 goes with the 6, 8 goes with the 16. That simplifies all to 1/2, so it's a 1 to 2. Either of these descriptions is a perfect way to say it. The smaller one is half the size, or the bigger one is twice as big. That's saying the same relationship, just two different ways. So we have similar rectangles here. We need to use the scale factor to find the value of x. So essentially you just want to be matching sides that you know go together. And we're just going to trust the way that it's drawn for us here. So this 10 goes with this 25. And this 20, because it's a rectangle, could go with this x. They don't have to be labeled on the same side. So we have that the 10 over 25, that relationship simplifies down to 2/5. Then we can use that. You don't have to simplify it, but it does say to determine the scale factor. So technically the 2/5 is that scale factor. So the smaller one is 2/5 the size. For every 2 pieces over here, there's 5 over here. So if it's 2 centimeters, it's 5 centimeters. 2 kilometers, it's 5 kilometers, whatever that label might be. Then we use that and use the 20. The x needs to go on top because that's where the 10 is coming from. So it's like 10 over 25, x over 20. Okay, small to large, small to large. X equals 8. Last one, determining the scale factor. These are just 4-sided figures here, quadrilaterals, but we can see which sides match up. I have the 20 matches with the y, the x matches with the 24, and the 40 matches with the 48. Notice that the 40 and the 48 are the only ones that you're given both numbers. The 20 goes with the y, so that's not going to help me with a scale factor. X goes with the 24, that's not going to help me with the scale factor. But the 40 and the 48 will help me with a scale factor. So using the 40 and the 48, that simplifies to 5/6. So the smaller one is 5/6 the size of the bigger one. Then we can use that 5/6, and you don't have to use the 5/6. You can use the 40 and the 48. You're just going to be getting much larger numbers. So if you use the simplified scale factor, the 5 is coming from the smaller one, 6 is coming from the bigger one. The x is coming from the smaller one, the 24 is coming from the bigger one. So small, big, matching sides, matching sides. Small, big, matching sides, matching sides. That's the pattern that we're using there to then cross multiply and solve. And this concludes the video for lesson 3. If you watch this, you can email me and tell me that my favorite color is purple, and you will get extra credit on the first quiz. I'll give you extra credit on the first quiz for watching and listening. Have a great day.